Welcome to Programming with Professor Califf. Today I want to introduce you to looping in Java with the while loop. One of the things that we've not yet talked about that is essential for writing most programs we might want to write is how to get the computer to repeat a block of code over and over again. A business wants to calculate pay for all of its employees, not just one or two per execution of our program. We want to figure out grades for all of the students in the class. The game needs to let us keep going until we lose or win. Some of these things we might be able to write a program for just by copying and pasting code, if we know how many employees and students we need to deal with, and the number is always the same. But copying and pasting is a bad idea in general. If we made a mistake, we have to fix all of the copies. Besides, we may need to do the same thing hundreds, thousands, even millions of times, and we often don't actually know how many times we need to do something. The number of employees or students varies, as does the length of most games. Fortunately, Java, like any other programming language, provides us with loops, which allow us to repeat sections of code. This is our second way to change the flow of control in our program, and is often referred to as repetition. Java provides three kinds of looping structures: while, for, and do while. You'll use both the while loop and the for loop frequently in programming. The do while is less common, but occasionally a great fit for a problem. In this video, I'm going to focus on the while loop. It is in some ways the simplest of the three structures, but it's also the most versatile. Anything I can do with a for loop or a do while loop, I can do with a while loop. So this is the basic structure of our while loop. We start with the keyword while, and then we have a condition in parentheses. The condition is basically the same thing as we would have in an if statement, simply something that evaluates to true or false. Then we have curly braces, again not required if we only have one statement in the while loop, similar to with the if statement, but always a good idea to have your curly braces for your loops. If you add debugging code, you're going to mess up your loop if you don't have braces. So always include those for any loop. Inside, we have the stuff we want to repeat, including something that's going to change the value of the condition. So what will happen is if the condition is true, we're going to execute what's in between the curly braces and then come back to the while and test the condition again. When the condition becomes false, we're going to fall out of the loop and move on to the rest of it. I've set up a little animation similar to what we did with the if. We're rolling along with our sequential statements, and we come to our loop structure. If it's true, we're going to go into the statements in the braces, the ones that our while loop controls, work through them, and then come back to our condition. If it's true again, we'll come into our loop again and work through. But when it's false, we'll go straight on to the next statement in our program. So I have a couple of examples. We have simply a program that is supposed to be grabbing an odd number. One thing that we often do with loops is actually check to see if the values we're getting are valid ones. That's useful for making sure our program works correctly, doesn't crash. It's good for dealing with users, making sure they're giving us the input we need from them. Good for security reasons as well. One of the ways we can crash programs, one of the ways denial of service attacks can occur is simply by feeding in bad data and crashing programs. So here I'm just, of course, creating a scanner, setting up a number variable to hold my odd number, and then asking for the number, reading it in. Now I want to make sure it's odd. So I've set up a while loop that checks to see if it's odd. Now that could be an if statement, but if it's an if statement, we only have one chance to get the user to get it right. By using a while, I'm allowing the user to keep trying and keep trying and keep trying, and he cannot get out of this while loop until actually entering an odd value. So then if it wasn't an odd value, we're going to come in here, print the number and that it's not odd, ask them to try again, get the next one, and come back and check to see if the new one's odd. And we won't come out of this loop then until an actual odd number is entered. And then we can fall out and go on with whatever it is we wanted to do with our odd number. Of course, another thing that we often do with loops is some form of counting. So in this particular case, I'm just adding up a set of numbers in a sequence. So we're starting with num is 1. We have a sum. We have the max number of what we want to add up. So then I'm checking is the current num less than or equal to the maximum number. If not, I'm going to print out that number and add that number to my sum that I'm trying to create, and then adding 1 to the number. This is very important. We need to change the number to make sure that we eventually get it up above max. And finally, we're going to print the sum. Let's switch over to Eclipse and see this in action. So here we have the first example I showed you. Look over it, make sure it's really the same, though I've added something where we just print the number once we get it. So let's run this. And when I go to enter the odd number, let's first just see that if we enter an odd number, we skip right over this. This was false to begin with, and so we don't execute anything inside the while loop. We just go down and do our print. Now if we run it again, and I put in an even number instead of an odd one, then we're actually going to execute the contents of our loop. And I'm going to enter a different even number. We'll go do it again. And note that it will keep doing this just as long as I want to come up with non-odd numbers. But as soon as I put in something that is odd, so that my loop condition becomes false, then we will go past the loop and do the rest of this. So let's move over to the counting loop. I'm going to first just, again, run this. And pull up things so you can see all of the output. So the sum of 1, 2, 3, 4, 5 is 15. Now I want to have us watch what's happening. So we're going to use that debugger that I showed you the last time. So I'm going to set a breakpoint right here on line 9 and choose debug as, flip over to the debug perspective, and let's watch what's happening here. So we have num, we have sum, and after we do this first step, we have the max. And of course, the next step will print. Now we're at our condition. So the condition is asking num less than or equal to max. So let's use our expressions capability and replace this one that's not relevant here with one that is relevant to us. And we'll see that right now that expression is true, which should make sense because 1 is less than or equal to 5. So then we're going to step, we print the number, do the sum, so now sum is 0 plus 1, or 1, and then we add 1 to num. So it will now become 2. And we go back to check our condition. Once again, we can see our condition is still true. So we'll step through, add the 2, add the 3, add the 4. At this point, our condition is still true because 5 is less than or equal to 5. So once again, print, add, num plus plus. Now at this point, if we look at our expression, it is now false because num is no longer less than or equal to max. And so when we step again, we'll fall out to our last print line and go on. I also want to show you, I mentioned that we need to make sure that we always modify things so that this condition value will change. So let's watch and see what happens if I forgot to do the addition. So let's see what happens if we do this without the num++. So now we're going to step. Now notice we're just adding 1 repeatedly. And the really frustrating thing about this is if we start, we can keep doing this forever. So I'm going to actually hit the resume, which will make it just run. And you'll see that it is just continuing to print 1s and print 1s and print 1s. And if I pause it, we'll see where it is right now. I'm going to actually do something called a step return, which will get us out of this print stream code back to our while so we can see where we are. And we just keep doing this, and it will go forever. We call these infinite loops. So whenever you have something where it's printing the same thing over and over again, or what's even worse is, let's go ahead and terminate this and modify it so that we also don't have the print, so that all we're doing is the addition and we can't see what's happening. And run it. So now this code is just running, and it's sitting here because I told it to go ahead and continue. It will run for a very, very long time. It is doing things. It looks like it's just not done anything and it's just hanging. If that is the case and you're in the debugger, of course, we can pause and see where we are. See that our sum has gotten ridiculous. It's actually gone very large and then very small. But sometimes you'll be in this situation in just the Java perspective, not debugging, but running. In that case, there will still be a little stop button here, and you can terminate. If you're not in Eclipse, you're running this somewhere else, you may find that Control-C will stop your program. It's very important to know how to kill a runaway program. Let's actually go back to our Java perspective and just plain run this with our infinite loop so that we can see what's happening. So I have this infinite loop running. It's just running, 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 running. The way I know the program is still running and not finished with no output, no more output, is that this terminate button is red. If I click on it, then it will stop the program and we'll get a message that the program has been terminated. So if you accidentally leave out whatever it is that should change this condition and make it turn false eventually, or write the condition wrong, there are different ways we can come up with an infinite loop. Then this is how you will stop your program if you're in Eclipse. Thanks for watching. In the next video, I will be talking more about a particular looping pattern called sentinel controlled looping.